All right, so we're going to hang a picture today, 8 by 10. We're going to have a putty background that solidifies into this nice sort of wood-looking thing. We're going to want to have a border around the picture. The putty thing is both the backing and the frame, and it's just going to be all flat. So basically, and we have 200 cubic inches of putty, which we want to use pretty much all of it, and we want to have it be 1/2 inch thick. Sorry, 2 inches thick. So that means that whatever the surface area is, we want a depth of 2 inches. So that means that basically you take 200 cubic inches divided by the 2 inches, and you get 100 square inches. So that's the area that we have to work with. Now, we have a 8 by 10. This is our picture. And then we want the frame to be uniform all around. So we're just going to have this thing, it's all X's, basically. And so this area here is what we want to calculate, and to be equal to 100. So that's the setup of the problem in terms of the picture. Now, so what is it in terms of the actual computation? Well, so what's the width? The width here is going to be x plus 8 plus x, and here it's 10 plus x plus x, right? And what's area? Area is length times width. And so we have 2x plus 8 times 2x plus 10 equals 100. Good, that's nice. So how do we proceed? Now you can multiply all that stuff out, use the quadratic formula. It's perfectly valid. It's a lot of work, quite frankly. I'm just going to first start with my favorite method of guess and check. So guess and check says x equals 0. Try that, because why not? This is actually a good starting point because the area that comes up with better be less than the area of the whole thing that you've got to work with, otherwise you got problems, right? And so x equals 0 leads to 8 times 10, so that's just the area of the picture, so that's 80. That's too small. Let's try x equals 1 and get a sense of the scale of this thing. X equals 1, we get 2 plus 8, which is 10, and 2 plus 10, which is 12, and so that's 120. All right, so 0 was 80, 1 was 120, and in the middle is what we want, is 100. So we take the middle as our next guess. X equals 1/2. Plugging in 1/2, you get 9 for the first factor and 11 for the second, so that's 99. It's pretty close to 100. That's almost 100. We're done. Okay, in terms of human needs, that would be it, right? So that's, wow. That was a very efficient guess and check. But we could go on. We could go on. Why, you say? So let's now go to our calculator. So in here, you can do something called y equals, and you can input a function. So type out 2x plus 8, and then times 2x plus 10. Voila. Now you can actually graph this thing. Looks like this. You can see at 0 it goes to through 80 and goes up to 100. If you just plop your finger on there and go up to where it's about 100, and you can see it's a little bit around 0.5, 1 something or other. You can hit the, I think you can hit the calc. Sure why that doesn't work. I don't know. Anyway, there is a table option where you can plug in your guesses. So you can do 0, 1, 0.5. That's nice. Now, the next thing I would do is 0.6. 103.04 versus 99. So 99 and 103, that's a difference of 4. I just want to go up 1 from 99, so that's 1/4. So I'm going to add 1/4 of the difference between 0.5 and 0.6. That was a point. So that was 0.1. A quarter of that is 0.025. So I'm just going to try 0.525. And wow, look at that, 100.0025. That's pretty darn good. Look at how few steps we did. That's really quick. All right, what if I wanted to do more? Well, that's a little too high, right, to get exactly to that. So I'll just do point, but it's really close. I'm just going to go try to see what happens if I do 0.5249. Yep, so it's in between those two. And I got 99.848 and 0025. So it looks like 0.0015 on that side and 25 there. So it's kind of like maybe a third. So I'm going to go 0.5293. All right, that's looking pretty good. Another 9 there. And still a little under the thing, so let's try 4. So it's definitely between those two. And you can keep on going, right? So at this point, it's utterly absurd to care about it in terms of the original problem. Good, glad we agreed on that. Now, so let's just move on to the next stage. Some methods for computing this exactly, because why not? So I've got, this is my original parabola. So this is going to be 0 when it's -4. 2x plus 8 equals 0. Subtract the 8, divide by 2, you get -4. And over here, that's going to be 0 when it's -5. So you got -4 and a -5. All right, so that's our parabola. It's facing up because there's no negatives in front of the x stuff. And so our vertex here is -4.5. That's halfway between -5 and -4. In particular, this distance here is 1/2. So that tells me, for my completing the square stuff, that I can write that part as x plus 4.5. You want to negate the vertex x coordinate there. And then it's, you square the length. So 1/2 squared is 1/4. Negate it, multiply by a, which in this case is 1, and you get -1/4. And that's all equal to 100. Nice. Oh, shoot. Sorry. There is something in front. Yeah, watch those. X is being multiplied by the 2's here. And so yeah, I should multiply that by 4. Yeah, because I have to multiply by a. So this is actually becoming, oh, that becomes 1. All right, good. So now I can solve it. 4 times x plus 4.5 squared equals 101. Add the 1 to the other side. divide by 4. Squared equals 101 divided by 4. Square root that, and bring that to 4.5. Now, from the picture, I know it's going to be to the right, because I want positive x, because I'm dealing with areas and whatever. And so I'll just do the plus here. Could have been a minus, but it's not. And that's my answer. All right, and let's go home. Minus 4.5 plus 101 raised to the 0.5 divided by 4. Shoot, what did I do? Oops, sorry. That was the square root of the whole thing. And do minus 9. And divide by 2. There we go. That's better. Minus 9 plus, so parentheses, minus 9 plus, let's say the square root of 101 divided by 2. There we go. 0.52493, which is basically what we agreed upon. 7 was close to 4 there, and you're good to go. Didn't use the quadratic formula. It's pretty simple. Obviously, the one thing to watch out for is what's multiplying the x's. Probably a good idea to factor that all at the beginning. So like I could have done this plus 4x plus 10, oops, plus 5 times 4 equals 100, or x plus 4 plus 5 equals 25. I could have done those things, although, then I would have created some other work, but, you do you. All right. Now let's do the quadratic formula. So first of all, you need to get everything in the standard form. So we're multiplying 2x and 8 and 2x and 10. So that's 4x squared. 2x 10 is 20x, and then this is 16x, and then this is 80. So we have, this thing is 4x squared, plus 1620x is 36x, plus 80 equals 100. Subtract the 100 to the other side. Minus 20 equals 0. And now we can proceed with the quadratic formula. Minus b is minus 36 plus or minus the square root of 36 squared. Okay, that's fun. Minus 4 times 4 times 20. Okay, that's not too bad. Divided by 2 times 4, or 8. Okay, so yeah. One thing I see immediately is, of course, the 36 is actually 9 times 4, right? Plus or minus. And so in here I've got 2 4s, so I could write this as 4 times 4. And then it's 9 squared minus 20. Is that actually minus 20 or is it plus 20? Oh, minus 4ac. C was negative, 4a is positive, so it's plus. Sorry, not bad. There we go. And then we got 2 times 4. Now this 4 times 4, oops. Okay. 4 times 4 comes out as a 4. And so, and then you can cross out those 4s. and you're left with minus 9 plus or minus the square root of 101. So 9 squared is 81 plus 20 divided by 2. All right, there you go. And we don't want the minus sign because that would make it all negative. And we're good to go. So that's the quadratic formula. It involves a lot more multiplication of stuff, I think. Although it's very straightforward algorithmically. Now let's go take a check how we might do things in GeoGebra. So first of all, let me put on the input bar here. And of course I can graph, just like I did in the calculator, I can graph my original thing. And it's pretty good to try to do this stuff without too much simplification before plugging it into something like this, particularly if you're checking it. All right, so that's y equals 100. Intersection. There you go. 0.52, and you can increase the rounding to 5 decimal places, or more if you like. And there we get our answer again. You can also plug in the quadratic that we plugged into the quadratic formula here. Minus 20, right? And we should get the same thing. There we go. 0.52494. Okay, great. What else can we do? So that's all about. Clear the screen. So that was all about graphing the parabola. That's already assuming that we did everything correctly, right? You could also try to basically graph the picture itself, right? And so this is a little bit trickier, I suppose, but you can start with this lower corner here being 0, 0, and then this corner being 0 and 2x plus 8, and so forth. That. So let's just do that. 0, 0. Oops, sorry. This is 2x plus 8, 0. 2x plus 8, 0. Oh, sorry. Don't want to use, do not use x in that fashion. So we'll call it 2. We'll call it a. We'll create a slider for that. And then what else we got? We got top, which is 2a plus 11. And then we have 2a 11, 2a plus 8, and 2a plus 11. So let's just zoom to fit this. There we go. We'll create a polygon. Give us the area. Like so. And where's the area? The area is 130. We can put that to show the value. There we go. Now with the, let's see if the slider just goes up and down. Of course, I don't have any fundamental constraints here in the picture. But we can do this. We can do a equals 0.52. What's it? Wasn't that supposed to be the answer somewhere? Did I? Oh, sorry. I switched to 8 by 11. Huh. Sorry, I've had that in my mind at times. That works. And now we can do nothing is infallible. Least of all me. What? Equals 0.524. There we go. So you can see that gets close. You can also put in there the inner picture. So the AA would be that lower left corner, and then let's see, going up is 10, and going up, plus 8, that other corner, and then I subtract that, and I got that, and now I've got my inner polygon, or square, or rectangle, sorry. Okay. And again, I can, well, it's just 80. Next time. And so now, as I drag my slider, you can see there that makes perfect sense. And then as I continue on, this thing doesn't really make any sense, right? Not bad. So here's a area. They seem to be overlapping here. And voila. So GeoGebra works nicely for both showing the geometric picture itself, in addition to also solving the quadratics by graphical means. And for a final confirmation, let's just go to Wolfram Alpha and equal to 100, hit solve, and there we go. Here are the solutions. Here's the approximate solutions that we found before, and we're good to go.